Hi, welcome back to Engineering Drawing. I'm your Dr. Vasu. We are going to see another problem in a line inclined to both the planes. Yeah, hope you are liking these videos. Do subscribe the channel. Right. Coming to this, a line AB 75 mm long, its a true length is given, and making 45 degrees angle with VP, that is angle phi is given, while its front view makes 55 degrees, that is alpha. This angle is alpha. Front view is making 55 degrees. Alpha is given. 1 and A position is given 10 mm above HP, 15 mm in front of VP. So you are asked to find its inclination with the HP, horizontal plane, and its projections. Let's draw the projections. So here, the point A, let's mark the point A here, 10 mm above HP. So the point is here at a height of 10 mm above the reference line. We call it as A dash, right? And 15 mm in front of VP. So in the same projector, we have this point at 15 mm. This is 15 actually. This 15 mm in front of VP. So this is point A. So A and A dash both are on the same projector. Now, let's mark the, suppose we are assuming the line parallel to HP. When the line is parallel to HP, its true length is visible, 75 mm long line, we can see it. Also, the angle with the vertical plane, 45 degrees is visible. So we draw a line here at 45 degrees angle and mark 75 mm, that is the true length of this line. Now, we call it as B2. B2 is the one initial position, and in this position, the line is parallel to HP, making angle only with the BP. Now let's draw the front view of this line and just draw the projector up to the reference line. And here, when you know the point B here, draw a locus of point B in the top view. That is parallel to the reference line passing through B. Now, this is the locus of B in the top view. Extend this and let's draw the front view of this line, that is B2 dash. Let's mark B2 dash here, and A dash B2 dash is the front view of this line. A B2 is the top view. So this is one initial position. Now let's mark another data here. Front view is making 55 degrees angle. So you know A dash. Let's draw a line A dash B dash at an angle of 55 degrees. So here, at 55 degrees, we have drawn a line here. And now the top view length, we don't know the front view length, how much this line is. We know that front view is on this line, but we don't know where B dash is actually lying. Coming to this initial position, we know when the line is making angle with the VP, we know the length of this line in the front view. That is A dash B2 dash. A dash B2 dash as radius, A dash as center. Let's draw an arc, right? Because the front view length of this line is this much only. It can't be more or less. So A dash as center, A dash B2 dash as radius. When you draw an arc, this intersects here, this line drawn at 55 degrees angle at some point. Now that point is the B dash, because A dash B dash is the front view of the line. Now we know the position of B here. Okay. Now we can draw the locus of B in the front view. Draw a line parallel to the reference line. That means the point B must be lying on this line only. So once we draw this line, point B is lying here. So this is the locus of B in the front view. Next, we know the true length of the line. We know the locus of the line, also true length of the line. I assume the line parallel to VP, that is another initial position. When the line is parallel to VP, its true length is visible in the front view. Because we know the locus of B in the front view, with the true length 75 mm radius from A dash, we draw an arc here intersecting this locus at a point called B1 dash. So this is the true length. And not only the true length, we also see the actual or the true inclination, that is theta with HP. So you can measure this angle theta, and that is the required angle with the HP. Okay. So like this, just we go on representing the data, we can find the final projections of the line and also the required angle here. Okay. So you draw the projector from B dash. We haven't drawn the top view yet. So we know the B dash. Once we know the B dash, draw a projector from B dash and here onto the locus here. When you draw the up to the locus, you get the B here in the top view. So mark B and join AB. That is the final top view. Now, the angle of this line, the final top view, making the apparent angle here, that is called beta. So you are given the apparent angle and the true inclination phi, but we are able to find theta and apparent angle beta. Okay, so like this, we'll be drawing the projections of the line and finding the required angles. Hope you had understood this topic well, and if you have any questions or queries, please do comment. Thank you.